Amazing! We did it! We have gone through 5 long chapters full of fundamental cryptography and reached chapter 6, which concludes this course with a recap and summary of all the things we have learned. This was a course that approached cryptography as a tool to realize the 4 classic security goals: confidentiality, integrity, authenticity, and non-repudiation. As a last recap of these security goals, confidentiality is the security goal demanding that information in a system is only accessible to an authorized party. Integrity is the security goal demanding that the correctness and completeness of information can be verified. Authenticity is the security goal that demands that in a system with authenticity, the source of information can always be verified by a party receiving the data. And non-repudiation as a security goal then demands that in a system with non-repudiation, the source of information can not only be verified by the receiving party, but that the source of information can be verified by any third party. For confidentiality, we got to see that the major concept provided by cryptography to realize this security goal in digital information systems is encryption. We got to know symmetric encryption with AES and the block cipher modes of operation ECB, CBC, and GCM. We got to know asymmetric encryption with RSA. We got to know hybrid encryption as a combination of symmetric encryption with asymmetric encryption to combine the best features of both worlds. And we got to know the key exchanges EDH and ECDHE that can be used to set up keys to be used with symmetric encryption systems. For integrity, we got to know cryptographic hash functions as the primary concept to use for integrity-related purposes, and got to understand that MD5 and SHA-1 are not collision-resistant hash functions anymore, and that MD5 and SHA-1 should, generally speaking, at most be used for legacy purposes. For new systems, SHA-2 and SHA-3 should be used, as SHA-2 and SHA-3 are up until today considered to be secure cryptographic hash functions, not vulnerable to the same attacks as MD5 and SHA-1. For authenticity, we got to see that multiple concepts exist where a first concept is represented by message authentication codes, for example in the form of HMACs, or where a second concept is authenticated encryption with associated data that is implemented by the Galois counter block cipher mode of operation GCM. Non-repudiation is then served by cryptography in the form of digital signature systems, where multiple flavors exist, and the 2 nowadays most recommended digital signature systems are the RSA-based RSA-PSS digital signature system and the elliptic curve-based digital signature system ED25519 and ED448. I think that this was all I wanted to say about the subject cryptography for this course. Before I fully close, I would like to briefly remind that the subject of this course was cryptography itself and not the application of cryptography, which is dealt with by other courses offered. I hope that with this course you could develop your understanding of cryptography as a tool to realize classic security goals, and of course I also hope that you just generally enjoyed the course and that we will get to see each other in another course as well. All the best and see you another day.